We're all familiar with the process for forming and pouring the deck slabs and also laying up the masonry infill walls. And that's how this building is constructed. So what is this panel? Well, this building consists of the high-rise portion, which we've been watching, and there's also an adjoining low-rise portion, just maybe 4 stories high. And they elected to do that low-rise portion with precast concrete, so we get to have a little look at that process. And this is one of the precast panels. When would you elect to use precast? Well, in the high-rise portion, where there's a repetitive process, the formwork gets to be reused many, many times, that becomes really efficient and cost-effective. But if you have a unique structure with very little form reuse, you may certainly want to consider precasting it. It is also tremendously influenced by the labor cost. If your project is a union project, the labor costs are very high, whereas the costs in the precast factory may be only a fraction of those costs. The decision was made here to proceed with precast elements for that low-rise portion, and we will get a chance to look at some of that procedure. This panel, every time I look at it, I think as soon as you go to pick it up, it's going to crack right over the door opening. This is a panel I would want to handle with extreme care. Also, you need to consider, can you get these panels to the site? Now, this panel is not very long, so getting it to the site was not a length issue, but sometimes it is, and you have to be certain you can deliver them. In this case, it was the height of the panel that was the restriction. You couldn't ship it vertically, it would be too tall. You couldn't ship it horizontally, it would be too wide. And under those circumstances, you usually tip it up on some kind of false work to make sure it meets the height and width restrictions. Nevertheless, it's probably an over-wide load, has to be delivered at night. All of these factors need to be taken into consideration. The element they're handling here is a double T section. This is a standard shape. The precaster owns those forms. Naturally, you want to limit your selection to available shapes to get the greatest economy. But there are many elements in this particular building which would be a one-of-a-kind. The walls all seem to be unique. The columns are especially complex because they require seats on them to accommodate the beams. So a lot of this forming in the shop is unique, but wherever possible, you limit your choices to elements which are standard. I'm sure there are also seismic concerns which have to be addressed with this kind of stick construction. This is obviously very different from the monolithic construction in the cast-in-place portion of the building. Precast elements are often used because of the speed of the construction. What is unusual here is that this small structure, perhaps only 4 stories, took just as long to build as the 40-story structure alongside of it. Now, that's not a reflection on precast. It could be that they simply didn't focus their attention on this structure until the end to make sure both units finished at the same time. But it did struck me as being rather odd that it took just as long to finish the precast portion. Precast elements are widely used in bridges, and they're not T-sections like these, but when they are erected alongside of one another, they're attached to each other. Now, I don't know if that's done in a building. In a bridge, it's essential to avoid any differential movement between adjoining sections. That may or may not be an issue in a building. In a bridge, you also seal that joint between adjoining elements. Again, is that done in a building? I'm not sure. When you're using precast elements in a building, of course, the utilities cannot be cast into the elements, or I suppose you could try to do that, but it would be a tremendous engineering challenge to have them come out where you really want them. So the utilities are added later, and they would be exposed. Depending on the nature of this space, that may or may not be acceptable. You may have to conceal the utilities using a hung ceiling or some other means. I want to review how quickly these buildings go up. This is an early stage. The piles have been driven. I don't know the duration of the pile driving. I arrived on the scene pretty much at this point when the piles had been driven and the foundation construction was just beginning. This is just a few months later, and 4 stories have been constructed. Now, this procedure did not go very quickly because the first story is the lobby, which is atypical and needs a different kind of forming, and of course everybody is going through the learning curve. The remaining stories are the typical pattern, and they go very, very quickly. So at this point, everybody has learned the dance, and you can erect almost 2 stories per week. At this visit, the building was about 50% done, and the rate they were achieving was just short of 2 stories per week. This is a summary of the schedule. The superstructure was done in about 9 months, and although I didn't witness the piles being driven, I think if you budgeted 3 months for the piles, that would be reasonable, in which case a building of this sort can be easily accomplished in 1 year.